The Virginia-class attack submarine has quietly dominated the world's oceans. Built to be cheaper than its Seawolf predecessor, but nearly as capable, the Virginia-class has gone on to become the cornerstone of America's undersea fleet and the most produced U.S. attack sub.
America's newest submarine, the Virginia-class, sounds almost unreal. It can stay underwater for months, travel across oceans without surfacing, launch missiles at distant targets, and quietly track other submarines without being seen.
From up here, you really get a sense of the enormity of this boat. She is a monster. Incredibly, this submarine will become essentially invisible, undetectable to anyone.
Sounds impressive, right? But inside, it doesn't look like much. Old periscopes are gone, replaced with digital camera masts and large screens. Some controls even use modified video game-style controllers. Built for the digital age, it's quieter, smarter, and more flexible. So why do many find it terrifying? Before the Virginia-class. To understand why the United States built the Virginia-class, we've got to travel back to the Cold War and the Soviet Union's advanced submarine capabilities during that era. Back in the 1980s, about a decade before the Cold War ended, the United States needed a submarine that could rival the Soviet Union's advanced nuclear-powered attack submarines, like the Akula class. The result was the Seawolf class, designed to be faster, quieter, and more capable than its Soviet counterparts. The Seawolf program began during the final phase of the Cold War. At that time, the US Navy was preparing for high-intensity naval conflict with the Soviet Union. The Soviet fleet was expanding rapidly, deploying increasingly capable nuclear-powered submarines with improved speed, depth performance, and missile systems. The Seawolf was designed specifically for that environment. It was built to outperform Soviet submarines in almost every metric: quieter propulsion, deeper diving limits, higher sustained speeds, and significantly more torpedo capacity. It incorporated state-of-the-art sonar systems and heavy structural reinforcement. If a Cold War undersea confrontation had escalated, the Seawolf would have been one of the Navy's most formidable assets. Technically, it worked. It was exceptionally capable. Many analysts still consider it one of the most powerful fast attack submarines ever constructed. But it didn't quite turn out the way it was meant to. Now, don't get it wrong. The problem was not performance. It was timing. While the first Seawolf boats were under construction, the Soviet Union collapsed in 1991. The central threat the submarine had been built to counter no longer existed in the same form. At the same time, the Seawolf program proved extremely expensive. Each boat cost well over $3 billion in 1990s currency, far more than originally projected. In a post-Cold War environment marked by defense budget reductions, that cost became difficult to justify. Instead of building the originally planned fleet of nearly 30 submarines, the Navy ultimately constructed only 3 Seawolf-class boats. The lesson was clear. Technological superiority alone was not enough. A submarine also had to be financially sustainable and strategically adaptable. By the mid-90s, the Navy faced a new reality. Global threats had shifted. Instead of preparing exclusively for deep ocean conflict with a peer superpower, the US was increasingly involved in regional conflicts, coastal operations, intelligence missions, and precision strike campaigns. The Navy needed a submarine that could operate quietly in shallow coastal waters, not just the deep Atlantic. It needed a platform that could launch cruise missiles at land targets, deploy special operations forces, gather intelligence near shorelines, and still maintain credible anti-submarine capabilities. It also needed to cost less per unit. This combination of strategic reassessment and fiscal pressure led to the development of the Virginia-class submarine. Where Seawolf prioritized peak Cold War performance at any cost, Virginia was designed around balance, stealth, versatility, and affordability within a changing global security environment. The shift from Seawolf to Virginia was not a downgrade. It was an adaptation that would change the Navy forever. How the Virginia-class was born. The Virginia-class submarine did not appear overnight. It was the result of the big shift inside the US Navy. Priorities had shifted, and the focus was now on building something more effective. Now, the question became simple. How do you build a submarine that is still very capable, but costs less and can handle more types of missions? This is how the Virginia-class program began. The US Navy worked with two major shipbuilders, General Dynamics Electric Boat and Huntington Ingalls Industries, the only two companies in the United States that build nuclear-powered submarines. Instead of competing against each other for separate designs, they teamed up. The submarines were built in parts at both shipyards and then assembled. This shared build approach was meant to reduce costs and keep both shipyards active. The first boat of the class, USS Virginia, SSN 774, was ordered in the late 90s and commissioned in 2004. Although it was meant to be an improved version of the Seawolf, from the start, the Virginia class was designed very differently from it. First, cost control was a priority. Engineers used more modular construction methods. Instead of building everything from scratch each time, they designed repeatable sections. This helped reduce long-term production costs. Second, versatility mattered more than extreme performance. The submarine had to operate not only in the deep ocean, but also in shallow coastal waters. These areas are notoriously harder to navigate and noisier, but they are where many modern conflicts take place. Third, technology changed. The Virginia class became one of the first US submarines designed fully around digital systems. It replaced the traditional optical periscope with photonics masts, essentially high-tech cameras that send images to screens inside the control room. This allowed more flexible interior design and reduced mechanical complexity. Finally, the submarine is powered by a nuclear reactor designed to last for its entire service life without needing refueling. That reduces maintenance time and long-term cost. Over time, the program was divided into blocks. Each block includes small improvements based on lessons learned. This gradual upgrade system allowed the Navy to improve the design without starting over completely. Today, more than 20 Virginia-class submarines are in service, with more being built. They form the backbone of the Navy's fast attack submarine force. And even though it was never created to be the most extreme submarine ever made, the Virginia-class is proving to be quite the creation. But how exactly does this submarine disappear? How the Virginia-class disappears. When people talk about how the Virginia-class submarine disappears under the ocean, they are really talking about acoustic stealth. That's the ability to avoid making noise that others can detect. To understand this, we have to look inside the submarine at how its power, movement, and structure all work together. Let's begin with the heart of the boat, its nuclear reactor. At the center of every Virginia-class submarine is a nuclear reactor, specifically a reactor known as the S9G reactor. So what is that, and what does it do? A nuclear reactor is a power plant inside the submarine.
Inside of a nuclear submarine. There's a lot going on here. This is one of the most powerful weapons in the world because of this. It's a nuclear reactor that breaks apart atoms to create an immense amount of energy.
Instead of burning fuel like a diesel engine, it uses nuclear fission, a process where atoms split and release a huge amount of heat. That heat is used to create steam. The steam then turns turbines, similar to the way steam turns turbine blades in a large power plant on land. These turbines then generate electricity and also drive the submarine's main propulsion system. Because the reactor does not need oxygen from the air to work, the submarine can stay underwater for long periods, months at a time, if supplies allow. The boat does not need to surface or use a snorkel to recharge batteries. That's one of the biggest reasons it can stay hidden. Next, the submarine doesn't have a traditional propeller. Instead, it uses a quiet pump jet. One of the biggest sources of noise on any submarine is the propeller. Most ships and older submarines use a traditional propeller, a set of exposed blades that spin in the water. When the blades spin fast enough, bubbles form and collapse around them in a process called cavitation. Those popping bubbles make noise. And that's the noise other submarines or ships can detect even at long distances. The Virginia class does something different. Instead of a traditional propeller, it uses a pump jet propulsor, a system that looks like a shrouded propeller inside a duct. Now, here's why that matters. First of all, the duct smooths the flow of water entering and leaving the blades. Then cavitation happens less often, even at higher speeds. And since less cavitation equals much less noise, the overall sound signature is lower, making the submarine harder to detect. That's one of the key engineering choices that helps this submarine disappear in the ocean. But even with a silent propulsion system, the submarine still needs to run pumps, motors, air systems, electronics, and other machines. Those things make vibration. If vibrations from machinery reach the hull, they transfer into the water and become sound that enemy sensors can pick up. Virginia-class submarines isolate almost all moving machinery. Engineers place major components on special mounts, which are basically vibration-absorbing supports that keep machines from shaking the hull. You can kind of compare this to the way a car's engine is mounted on rubber blocks to stop it from shaking the whole frame. Every vibration reduced means less noise radiated into the water. Finally, the submarine's hull shape and coating itself also affect how quiet it is. Because smooth flow reduces turbulence and noise, the hull is designed so that water flows as smoothly as possible over its surface. In addition to that, special tiles called anechoic tiles are placed on the outside of the hull. They are made of rubbery, sound-absorbing material and serve two purposes. One, they dampen noise from inside the submarine so less escapes into the ocean. And two, they help absorb or scatter active sonar pings, the sound pulses that another vessel might send out to try to detect objects underwater. While this doesn't exactly make the submarine invisible, it reduces its sonar return, making it harder to spot with active sonar. Now, let's turn our attention to something just as important. How far down does the submarine travel? How deep can it go? The exact maximum safe depth of US submarines, like the Virginia-class, is classified, meaning the Navy does not publicly reveal an exact number. While it can come across a bit secretive, it's actually for good reason, because knowing how deep a submarine can operate gives potential adversaries information they could use to locate it or counter it. However, we can say with confidence that the Virginia-class is designed to operate at significant depths suitable for deep ocean tasks, that it can dive deeper than most surface ships and shallow draft vessels, and its pressure hull is made of high-strength steel, allowing it to withstand the increasing water pressure as depth increases. Instead of an exact number, think of it this way. The submarine can operate in depths where detection and tracking are difficult for most surface-based systems, and that's where sonar comes in. Submarines use sonar to detect other vessels. If you don't know what that is, it's basically underwater hearing. Sonar uses sound waves to understand what is happening in the water around the submarine. There are two main types, passive and active. Think of passive sonar like listening quietly. The submarine does not make any sound. Instead, it listens for noises made by other ships or submarines, the hum of engines, the vibration of propellers, or even water moving against the hull. Passive sonar is a bit on the safer side because it does not reveal the submarine's own location. Active sonar, on the other hand, is kind of like shouting and listening for the echo. The submarine sends out a sound pulse into the water and then measures how long it takes to bounce back from an object. This gives the submarine information about where something is. It's pretty accurate, but like you probably already guessed, the downside is that active sonar can reveal the submarine's own position to others. Now, the Virginia-class submarine has an advanced sonar system called the AN/BQ-Q-10, which combines multiple sonar arrays like the bow array located at the front, which listens in many directions at once. There are also the flank arrays on the sides of the hull. These help detect objects that aren't directly in front of the sub. Finally, there's the towed array, a long cable with hydrophones, underwater microphones, that trails behind the submarine, far from its own noise. The towed array is especially important because it is far from the submarine's own noise and can listen more clearly for distant sounds. Because the submarine itself is already so quiet, thanks to the nuclear reactor, pump jet, vibration isolation, and hull design, its passive sonar works much better. It can pick up the faint noises of other vessels without being detected itself. This combination of quiet operation and advanced sonar is what allows the Virginia-class to see the ocean around it without giving away its own position. Plus, it can also track surface ships, other submarines, and even underwater hazards while remaining hidden in plain sight. Wonderful, isn't it? Regardless, operating quietly is not just about hardware design. It's also about how the submarine is run. And that's where power management and silent operation come to play. power management, and silent operation. If the submarine is trying to hide, the crew will move at low speeds. Faster movement creates more noise, even with a pump jet. Operating quietly means balancing speed and stealth. The nuclear reactor gives the submarine the power to choose how it moves. It can go fast when needed, or creep slowly and silently when trying to avoid detection. Everything about the Virginia-class design, the nuclear core, the pump jet, the isolation mounts, the hull coatings, the sonar systems, and even the way the crew operates the boat, works together to minimize noise and maximize tactical surprise. While it might look like magic on the outside, it's simply engineering. But while the boat's strength might lie in its acoustic stealth, the Virginia-class also boasts an impressive array of weapons and mission capabilities. Weapons and mission capabilities. When people talk about America's submarines disappearing underwater, it's easy to forget the other side of the story, what these submarines can do once they're in position. The Virginia-class is not just designed to avoid detection, it is a weapons system, a tool for many kinds of missions, from hunting enemy submarines to striking targets on land, from supporting special operations forces to controlling important sea lanes. Let's break down exactly what it carries and why that matters. Number 1. Torpedoes and missiles. The Virginia-class carries powerful weapons that let it engage threats, both underwater and across great distances. At the front of the submarine are 4 533mm torpedo tubes. These tubes launch the submarine's primary anti-ship and anti-submarine weapons. Most commonly, these tubes fire the Mark 48 heavyweight torpedo, a large, powerful torpedo that can track fast, maneuvering targets like another submarine or a warship, and uses onboard sonar and guidance systems to home in on its target after being launched. Torpedoes are the primary close-range weapon for submarines, lethal and precise in underwater combat. Then there are long-range cruise missiles, which Virginia-class submarines can launch from vertical launch tubes. Early versions of the submarine carried up to 12 vertical launch tubes designed for the Tomahawk cruise missile, a land attack missile that can travel hundreds of miles from the submarine to a surface target. This missile uses GPS and onboard guidance systems to hit with precision, and also gives the submarine the ability to strike land targets without surfacing or using aircraft. This mix of torpedoes and cruise missiles makes the Virginia-class both a danger to enemy fleets and a tool for long-range offensive operations. Number 2 is the Virginia payload module that brings more firepower. As the Virginia-class evolved, naval planners wanted even more firepower and flexibility. That's where the Virginia payload module, VPM, comes in. The VPM is an additional section inserted into the submarine's hull in later variants, called Block 5 and beyond. It adds 4 large vertical tubes that can hold many more cruise missiles. But what exactly does it do? It expands the submarine's missile capacity from about 12 missiles to potentially up to 40 cruise missiles. This allows a single submarine to carry nearly as many long-range strike weapons as some surface warships. In turn, it increases the submarine's strike reach without needing escort ships or aircraft. In conflict scenarios, that is significant. A single Virginia-class with VPM can launch a coordinated missile strike against multiple distant targets while remaining underwater and hard to find. Number 3. Special operations and unmanned systems. The submarine's missions go beyond torpedoes and missiles. Virginia-class submarines are designed to support special operations forces such as Navy SEALs.
As we've already mentioned in passing, they aren't just stealthy killers, they're multi-mission platforms that excel in both peacetime and war. Virginia can lurk near hostile coastlines for weeks, eavesdropping on communications, monitoring radar activity, and mapping seabed installations, all while remaining essentially invisible.
They can deploy small craft or divers without surfacing through structures called dry deck shelters. These detachable pods attach to the submarine's hull and act like underwater hangars. This allows special forces to enter or exit covertly, reconnaissance teams to gather intelligence, and mine-clearing units to operate near contested coastlines. But the mission expansion doesn't stop there. Virginia-class boats are also prepared to work with unmanned underwater vehicles, UUVs, and other robotics. UUVs are kind of like underwater drones that map the seabed, search for mines, gather acoustic data, and scout ahead of the manned submarine. These vehicles can be launched and recovered while the submarine stays hidden, increasing the range and safety of reconnaissance missions. With significant prowess like this, the Virginia-class submarines are here to stay, especially because they combine stealth with flexibility, precision, and networked capabilities. Their quiet patrols act as a strong deterrent. Adversaries can't easily locate them, and they can strike targets without warning. In the Indo-Pacific, under the AUKUS Pact, these submarines help strengthen alliances, maintain sea lane stability, and create shared undersea forces with Australia. More broadly, Virginia-class boats are not just hidden weapons, they are versatile platforms. They defend against enemy ships and submarines, strike land targets, support special operations, and integrate unmanned systems, forming a key part of US naval strategy. So, should these Virginia-class submarines truly be feared? Tell us what you think in the comments below. Thanks for watching. Please leave a like and subscribe to the channel for more videos like this.